you're kind of okay, right? You're hanging on. I was looking at the stuff that I have taught. I've taught a lot of things within this 5 days. I only have I've been teaching on 5 days, right? 5 days. 5, right? Or is it 6? So that's a lot of information to process. But I think you'll be okay. Engineering. The other thing I would engineering, you guys should be up to speed, right? And also remember, as you go through engineering, you will find out that there are some missing information, right, that the lecturers will assume. Because all these lecturers who come here have come from different parts of the classes given. So unless you indicate to them which portions are not comfortable, they will just go on, right? And then after that later don't come and tell us, oh, I didn't understand this whole part. So here you have to don't wait until the feedback form comes. That's too late. So get your lectures, your lectures are here, and then where's the lecture? Where's the lecture? Okay, you're also one of them. Now I told you folks that there is this guy who is going to teach the topics numbers. I asked her also this morning. She said you guys never came and told. So it's up to you to figure out where time slot is. Yeah? You had nothing to do with it. I think it was the other guy. So now, don't come and tell us that you didn't do it first. Right? So you need to come and howl at the whatever I guess rest. Say that what the I do, you need to go and set it up. Right? And then we can get answers from my teacher. Now it's too late. Also you have lectures in the afternoon after the sustainable, right? Mechanics. I think the sustainable lecture is basically cancelled, and the mechanics person is coming. Professor Ranavira is coming at 1. I think that's the deal, right? Anyway, you're having lectures on Friday from mechanics. Okay. Let's get back to this. Okay. Folks. Lectures are tomorrow, student. Right? So now for D, you are supposed to find not for each element, but you are supposed to find it for the entire system. Now, entire system is E and IS. Right? So we have identified E and IS. Here we are. Let me put it here. Over here, E was 20 with an angle of 0. 20 volts with an angle of 0, and then IS was 10.1 with an angle of minus 6 degrees. Was it minus 6 degrees? Minus 6 degrees. Right? 10.1 amperes with minus 6 degrees. Now what you do is you are supposed to find the total active power, total, right, reactive power, and total, I guess, apparent signal power, and FP is FP is actually the power factor, right? I would have expected it to be PF, right? Power factor, right? So you are supposed to find this. So if you know E and I, you have E. This is 20. Then this is minus 6 degrees, that is I, V and I, that is 10.1. Immediately you know that or maybe FP, I call the power factor PF, right? FP is equal to cosine of the angle difference between the V and the I, right? Anywhere you have a V and I, you can find the power factor as it goes through that element. So it is cosine of 6 degrees, whatever that is, right? It's about 0.9, right? Yeah, how much is it? 0.9? 0.995. Okay, so that's found. Now you have to find the total signal power. What is the total signal power? VRMS and then IRMS cosine of phi. Angle difference between V and I. Now I think some student came and asked me, right, whether you can use this equation, the VRMS, IRMS, with all the other stuff as well. Sure, you can. I didn't ask you not to. Now, for example, here you could have used that equation, right? You need to have VRMS, which should have been. Now, remember, if it is in R theta format, it is already in RMS, right? It's already in RMS. So you would have had RMS V is 20, right? RMS into 20. Now here, if you look at this one, you have the I of R and V is this one, right? So you would have 20, which is VRMS, and IRMS equals to 10, and the cosine of the angle between those two. So angle between this one is what? Angle between what is I and V is what? Is 0. So cosine 0, which is what? 200 what? There you go. I could have used that also. Then if I wanted to calculate the reactive power, I had to take VRMS, right? VRMS into what? Base IRMS, and I have to have sine of the angle difference between them. Angle difference is 0. So VRMS IRMS times sine of 0 would have given you 0. You can do that too, but using I squared R when you are looking at individual elements, it's cleaner. But don't, I said for any, this is what I said. I said for whatever V and I across anything, right? V and I across anything, this RMS value of V into RMS value of I and the angle difference, you can find either the cosine or sine, would have given you the active power or the reactive power, right? So here, I want to find the active power, so I have the VRMS is 20 and IRM is equal to 10.1 and cosine of the angle difference between them, which is 6 degrees. That is what? That is the total signal, total active signal power, or what we call the average power. Then I have the reactive power, the total reactive power of the circuit is, which is which is actually VRMS into IRMS sine 6 degrees, VARS. There you are. Then ST is just VI, 20 times 10.1 volt ampere. Or if I want to put it, I would put PT plus J of capital QT, and I will take the magnitude if I want to give a single number, or I can just leave it as PT plus JQT. That is apparent power. We found the power factor also, right? All these are very straightforward equations. You just have to try it out and then get a little bit of practice. If you do that, you can get also the 25% that I am planning on giving you. Okay, what is the rest? Sketch the power triangle. We already know what IS is, right? Sketch the power triangle. But you could also have calculated P total by doing what? By adding up all of the elements. Each one where you have the average power, you add up, you would have got the same answer, right? Or at least somewhere close to that same answer. Then sketch that's very simple, no? You sketch the power triangle. This should be PT, that should be QT, right? That's how you sketch it. And this should be ST. They should match up. And IS we already found, right? Okay. How about this? How do I do this? Now the question is, do I need to do this? Huh? I dropped all the DC ones because why? I guess moment I convert this into AC circuit and put whatever the boxes, it's almost like if you are applying it to a DC circuit, right? So if I teach you this, in fact the DC one is already in. So at least for this question, we will go through the whole sequence. Right? So this question goes through. What does it say? It says the Thevenin equivalent circuit for the circuit where extra element between point A and B. So this is taken as a load, right? This is taken as a load. So they ask you to find the equivalent circuit for all that, right? For all that. That's the problem statement. So I would first of all, what I would do if I get an AC circuit like this, convert it into, if I get a circuit with all AC sources and so on, I would convert it into a simple AC circuit. How would I do that? Page after page after. Right? How would I do that? I would look at the circuit, and wherever there are impedances, I would put like boxes. Now remember, ladies and gentlemen, let's say for example over here, I had a circuit like this, right? And then I have the inductor and blah blah blah, right? Let's say don't put two boxes for this. Why would I do that? Because this is an impedance, that is an impedance. So if this was R, this would have been like minus J of XC. I would place this with a single box. Otherwise your equations get like, I guess, more complicated for what? So I would put a single box like this here and then call Z R minus J of XC. I'll just add these two together and put it. This is what you would do if I had two, right, resistors together. What would I do? Would I take them as two separate pieces? No, I would actually make it singular. So I put single box by considering both. I think that was also one of the questions somebody asked me. Okay, so here I don't have such situations, but I will have such situations in the future. I have to convert this into a reasonably good looking AC circuit. So how would I do that? I have my thing here. Over here I'll put a box, Z1. Over here I'll put a box. Then over here I will put a box. Then over here I will have the current source, and over here I will have an open circuit. I'll call this Z1. I'll call this Z2, I'll call this Z3, and then I draw a straight line across here and I put Z1, Z2, Z3 on the other side. This would be 120 volts with an angle of 0 degrees. This is 0.5 amperes with an angle of 60 degrees. And I have Z1 is actually R, which is equal to 10. And I would also put it down as the R theta format in case I want to go between them. So this will be 10 with an angle of 0. Then I have Z2, which is J times 8, because this is an inductor, it is J times 8. This is this is XL that they give, and that would be 8 with an angle of 90 if you put it into R theta format, right? And if I have Z3, that is going to be equal to what? Minus J of 8, and that's going to be equal to 8 with an angle of minus 90. So I have it on the side of my page. Now I start calculating. Right? Now I do my thing. So this is A and B. I have eliminated the ZL. What is the next step now? Now once I bring it down into these boxes, rest of it is the DC analysis. All the equations that I use for all that analysis works here. Same way. You don't have to change anything. Right? So the first thing I would do here is what? I want to find the equivalent impedance basically Thevenin impedance, I would have to do what? I would have to take out all the sources by replacing them with their internal impedances. If it is a voltage source, I don't care whether it is AC or DC, will be replaced by a short circuit. If it is a current source, it will be replaced by an open circuit. So if I do that, I realize I get a circuit like this. A and B, you look through this, R of TH, this is Z3, this is Z2, because I put a short circuit here, Z1 will turn out to be in parallel with Z2. So immediately R of TH is what? Z1 will be in parallel with the Z2, and then onto that you have to add Z3, because Z3 would be in series with that parallel combination. Right? That's done. The first phase is done. So now what I do is, once I have this equation, I can start to substitute and find the answer. Right? You can I guess wait until the end to do this, the answer, getting the answer by putting the actual substituted values. Now what I have to do is to find the open circuit voltage across here. Because why? They want you to find the Thevenin equivalent circuit, right, between A and B. So I have to find the open circuit voltage from here. How would I do that? Let me take this out. There you are. I have to find the open circuit voltage. Open circuit voltage. Which method would I use to do this? Yes? Which method would I use to do this? If I use nodal analysis, my answer will be automatically there. Right? But if I use mesh also, it's easier because there is basically a current source in a link. Right? Any other method that's easier than that? No, right? I mean, both methods are equally hard. Right? Both methods are equally hard. So here, I would draw this loop current as I1, that loop current as I2. Then there is some amount of ambiguity on this link because both currents are flowing through that. I would mark it as I1, and I know I1 is equal to small I1 take away small I2. Now I would write the equations. Right? So I would apply the Kirchhoff voltage law to loop 1. You will have 120 volts with a 0 degree angle. Of course, you realize when this goes in the clockwise direction, voltage drop is that way, clockwise voltage drop is that way. Over here you can't apply the Kirchhoff voltage law because of this, but it's okay because why? We know I2 is what? Minus 0.5 with an angle of 60 degrees. So here you will have minus of I1 Z1, right? You got minus of I1 minus I2 times Z2 equals to 0, and then here you will get I2 to be equal to, right, minus 0.5 amperes with an angle of 60, because this loop has to go through this source, and the source is going opposite to the way in which the loop current goes. So I2 is known. You have to find I1. Right? You have to find I1. How do I find I1? So I1 would be equal to 120 with an angle of 0. I have dropped the V because I know it's a voltage. I will have plus, I got I2 into Z2. So I got, this is minus 0.5 with an angle of 60 times Z2, now I already know, is equal to 8 with an angle of 90. Right? 8 with an angle of 90 over, right? So you realize that this one, this is minus, it becomes I2. It becomes basically plus I2 times Z2, but I2 is minus, so that's the minus comes in. And over here, Z1 plus Z2. Z1 is 10, Z2 is 890. Z1 is 10 plus 8 with 90. Now, I think somebody asked me the question, if I have R1 and my 1 is theta 1 into R2 with an angle of theta 2, I have told you according to complex numbers, this is equal to R1, R2, but the angles will add up. Theta 1 plus theta 2. Right? And if it was R1 with an angle of theta 1 over R2 with an angle of theta 2, then according to complex number theory, that becomes R1 over R2 with an angle of theta 1 minus theta 2. Right? Now you got to find I1. Here's where you are going to have trouble. This is what multiplication is always easy to use. So this will be equal to what? This will be equal to 120 with an angle of 0. Right? This becomes minus 4, and the angles will add up. It's 150 over 10 with an angle of 0 plus 8 with an angle of 90. So you have to convert now. This is an addition and a subtraction. So you have to convert from R theta into the Cartesian format. Cartesian, and then not easy. That's why I said don't do that until you hit the end of the problem. Right? Hit the end of the problem. Then you have to find the open circuit voltage, which is, this is the open circuit voltage. Right? So if I put down it in the form of an equation, V open circuit is equal to, right? Now this goes that way, this goes this way, that goes this way. V open circuit is equal to small I1, right, minus I2 Z2, that is this voltage, take away, right, that voltage which is I2 times Z3. Right? See, this voltage take away, because this is going that way, so the voltage is going this way. This minus that is this voltage. So I can calculate that. Now I know Z2, I know Z3, I know I1, I know I2, I know Z2. I can calculate this. Right? Then what you have is V open circuit and RTH. You can now hook it back up onto that resistance which was called CL. Right? This is the way you do all problems. Right? Now I know there were some questions asked. There were some questions that were asked. I guess what would happen if my circuitry looks really bad? Like for example, you have a circuit like this. right? On top of that, the application of it is still the same, right? But here's a clue: you don't have such circuit in your examination paper. So we will do this problem after the exam, right? I'll take a problem like this where you got hats and stuff like that all over the place, or maybe even something like this, and show you how it is analyzed, right? But right now for examinations you don't need that. Is that okay with you folks? Any questions I can answer? All these are straightforward questions, right? Here. Now here also they ask you to find this Norton equivalent circuit. You must notice now after doing several problems I am a little bored, right? My enthusiasm is now right here. Right. Okay. So now you realize there are two elements. If you look at this, there are two elements which are now considered to be a load. Two elements considered to be load. So what do? If that is the load, you take that whole thing out. Right? You take this whole thing out and then you find this Norton equivalent circuit. Right? If you do that Norton equivalent circuit, you will come out with a current source like this and a resistor like this. Right? Where this is I of short circuit, this is going to be RTH, and then on top of that you will add the resistor and the voltage source. So you can even take the whole circuit, part of a circuit, to be a load, right? And then consider the other part and then find an equivalent circuit. Okay, I just want to do an additional problem on phasor diagrams, right? If you really want me to do these problems, I'll do it, right? It's better that you do it yourself. You know how it's done, right? Or I can answer some other questions that you have in the class, but I will do one for the phasor diagram. Now there was a question by somebody saying, right? There was a question by somebody. All of this time I drew the phasor diagrams for circuits which had elements that are in series and elements that are all the elements are in parallel. I didn't draw a phasor diagram for something that had both the series and the parallel sort of system. So I will take one and show you how it is drawn. Let's say, for example, you had a circuit like, I just took an arbitrary circuit. I didn't have a particular circuit. This is a capacitor, it's a resistor and an inductor. Right? Let's say this was E, that was XC, that was R, and this was XL. Right? Now I ask you to draw the phasor diagram for this whole thing. Now, when we drew the phasor diagram, it was between like what and what? It was between I and B. Right? The phasor diagram had only I and B. Now, when we drew the phasor diagram, I gave you a simple rule. What was the rule? Yes, what was the rule I gave? Huh? No. Civil, I saw you at a civil engineering lecture after that. Yeah, civil. When I said when you are drawing the phasor diagram, what was the rule I gave you to draw? Yes. I asked you to take something for the horizontal line, right? What was the reference? Huh? Yeah, I did a reference. What did I ask you to take for the reference? The common, right, variable. Right? Now, basically, if you had a circuit with only series, right? Let's say, for example, something like this. See, if you had a resistive, inductive and a capacitive circuit like this, there is no question. Because why? If it was like this, E is the one that is going to get split, and I would have been the common element. So you would basically have I as your reference, and then on top of that, you realize R will have the V in the same direction, and L will have what? Now you are using that rule, right? You have V, which is going to lead the I, and then for the other one, VC, you will have the I, which is leading V. So that's what you did, right? Perfect. Now, if you had a circuit where all three elements were in parallel, all three elements are in parallel, you realize the one element or like one parameter which is going to be common to all the elements are what? E, right? I is the one that is going to get split now. So this is IR, this is IL, and that was IC. So immediately what did you do? You took E as your reference, and you realize there was a resistance, which means you also have IR in the same direction. Then you have an inductance. You realize we should lag, you should have E, which is going to lead I. Then for a capacitor, you have I, which is going to lead B. Which is also fine, right? Not a problem here. Now if it was like this, there is no problem. But what happens if I have two elements where E is going to be common to this, common to that, but inside here you have I being common to both R and L. So what I am saying is, if you have a situation where series and parallel combinations, how that works, right? Still the same rule applies. Right? Still the same rule applies. What is the rule? Basically the rule says, pick out the common element first, put it as a reference. Now here, your common element is what? Common element is I. So you put I. Of course the phasor values and things have to be calculated, right? Then R will have a, right, VR going in the same direction because there is no angle difference. Then this is an inductor. Inductor is what? Yes. You need to have inductance V that is going to lead, right? VL, which is going to lead your I. This is fine, right? Now what happens is that portion is E, and E is the one that is going to be common to the two parallel elements, right? Two parallel elements. So you have to first of all find E. Now E is what? E is the vector addition of VR and VL, right? VR and VL. How do I do that? You have something called the parallelogram law, right? So I use the parallelogram law, and I am going to draw the E, right? Now if I look at E, that I has to be what? Yes, 90 degrees leading. So this I have to draw, let me use this. I have to make sure that this is 90 degrees leading when I draw IC. Because why? It has to be drawn with respect to E. That is the phasor diagram for series and parallel. I used only the single rule. What is the rule? When you draw the phasor diagram, pick the common variable. That is the reference. And on top of that, I keep adding. And if you were smart, you would also have picked up, you also would have realized I picked up the one which has the most elements first. See, I didn't start with the one which has the capacity. I start with the one which has most elements and then do backwards. So now, even if I give you series parallel combinations, you don't care. Right? Any combination now you can draw. Now let's say for example you got something like this. Let's say you had something like this. We will say you had a circuit. Maybe I'll go to the next page. Right? We will say you had a situation like this. Right? This was XC, R, and XL. Right? Now, remember AC theory, the way you are going to find all these voltage drops and so on, we are not going to concentrate because we already know these things. The magnitudes are defined, we already know. Right? Using analysis. How do I solve this one? If I take XC, what is common and what is going to be parallel? What is going to be common and what is not common? Now the phasor diagram should come with whatever this variables that you already have in there. Right? Start with the rules that you know. It says what? Rule says pick the common variable that is picked as the reference. So this is I, let's say I. This is IR, that is IL. You realize over here there is a common voltage which is not equal to E. There is something else in here. Right? Something else in here. So you have no choice but to have another variable Vx in there somewhere. Then in terms of Vx, you have IR going in the same direction, right? This one goes that way, right? Goes that way. Now you realize capital I is the addition of IR plus IL, right? Addition of IR plus IL. So what do? I have IR, I have IL, I find the resultant of it, which is I. Once I have that, this one is going to be what? Yes? Yes, this one is going to be C. Voltage Vc has to lag the I by 90 degrees. Right? Okay. Now you have Vx and Vc should add up to give you E. Yeah? E is equal to Vc plus Vx. This is Vc. See, this is Vc, this is Vx. How do I do this? I do the parallelogram law, and that would be my E. Right? So if you don't want to have this Vx in your system, you can eliminate it. But it's better to keep it because you know how it has been done. Again, look at this whole thing. What did I use? Only rule I used was what is the common variable that goes. Now using this, please practice because the phasor diagrams will end up in your midterm. Right? Maybe not so complicated now, but at least you should know how to draw the phasor diagram. Right? So if there is no particular questions, let me stop here because you realize that my enthusiasm is very low level now. Yeah? No energy. But if you ask a question, I will bring back my energy into a glass of water and then I will teach you. Any other things that you want me to explain? Any other areas or other than I don't understand lecture systems? So you folks are okay? Yeah? And look, here, I feel very confident when I look at your student feedback. Right? Listen, important part. Very confident when I looked at your student feedback. Almost 65. A person of you said that you are going to get A's in the class. Either you are dreaming or you guys are really, really good. I would prefer to go with the first one. I'm surprised. For 65% of I will upload it. 65% is. So now don't say things like that to lecture. That's very good. Level of the day. Bad news. No. I'm building it this time scientific. Anyway, it's difficult. Right? So don't worry about it. That part, that information isn't help me at all to change my mind. Anyway, that. Okay, so if you don't have any other questions, can I stop here? Let me go over the phasor diagram again. Okay, listen, right? Let's go over the phasor diagram. Okay, what was the rule? Rule is, there's another question. Rule is find the common parameter, use it as the reference. You realize for these two, you have Vx, some voltage, we don't know what the hell that voltage is, some voltage, that is going to be the variable. If you don't want to call it Vx, call it Vr, because it is in fact the right voltage that is across R, right? So for that part of the circuit, you are using a reference called Vr, right? Then basically looking at it, you find out the other variable that is split. That is IR and IL. Those are the ones that are different. And you draw for that. So, again you are using the civil. Here, this is a resistor. We know that the IR should be in phase. That phasor should be in phase with VR. No problem. You then find out IL, right? Then basically across the inductor, you should have V that is going to lead I. So obviously IL should be going right that way. Now you realize base IL plus IR is the one that gives you I here. Let's call it IC. Right? Let's call it IC. That's what is going here. So if you are adding two things vectorial, what do? You use the basically parallelogram law. So there you are. You are going to use the parallelogram law. Right? Then you find the actual direction of IC is that. Right? Now if I know IC, I know VC has to be what? VC has to lag this IC by, see, by 90 degrees. So I have to like lag VC by 90 degrees. Lag VC by 90 degrees. Right? So now we got all that part. Now there is an additional one, E. You know E is the addition of VC and like VR. How do I add? I have to still use the parallelogram law. Right? You have, this is VR. Right? And then, okay, that didn't work out nicely, did it? Anyway, maybe the actual, when you change the heights and so on, it might be different, right? So I'll change the height here a little bit. Otherwise it become pretty messy, right? Right? Let's say it was basically here, VC. So now you have to take VR and put it together with this, and that's where you are going to have E. Right? Takes a while to understand the case, right? Takes a while to understand the case. You need practice. I think in the book there are about 5 to 6 examples that they have like worked. Go through them. Right? Okay, here's what I'm going to do. All of the questions that I am going to receive, all the questions that I am going to receive after the class, I will upload them, upload the answers as videos. Right? So on the internet I will place where each time a person asks a question, I will answer it by talking and videotaping it, and I'll upload. Right? Because you don't have time to now figure out things. Right? How to solve this? Okay. That's a good question. Here, I'll tell you, ladies and gentlemen, you can understand phasors much easy than manipulating complex numbers. I hate complex numbers because it's so tedious, right? So please make sure you understand how to put those things into the calculator and get the answers, right? Because otherwise you are going to be stuck with this. Also, don't spend too much if the answer is not asked for. Right? Don't even have to substitute. I'll give you only 3-4 marks for that. Drop it, because you'll be spending a lot of time doing that to get those 2 marks. Unless, of course, that part is necessary for the other part. In which case, you have to do the calculation, right? Here. This is the question. Don't break anything. 120 with an angle of 0 minus 4 with an angle of 150 over 10 with an angle of 0 minus 8 with an angle of 90. There is no easy way to do this. Right? You have to use the R theta format. How do I do this? Here I will take 120 with an angle of 0 is equal to 120. Right? 4 with an angle of 150 is equal to 4 times cosine of 150 plus j times 4 of sine 150. Right? No easy way out. So how much is this? How much is cosine of 150? Right? So it is cosine 150 times pi over 180 will give you like minus 0.866. So this is minus 0.866 times 4. Right? Here sine 0.5 So plus J2, right? Okay, I am surprised at that answer. I'm surprised by that answer, but anyway, right? Anyway, this is how you do it, right? So you have this. Now here, what is it? This is about 0.9. Please approximate. Don't worry. This is about 0.9. So this is about 3.6, right? Plus J2. Okay? And then you got this, which is equal to 10. Then you got 8 into 90, which is like J8. Right? Now you substitute here. So do it on the side. Now you substitute. 120 is 120. This is minus 3.6 plus J2 over, this is equal to 10, this is minus J8. How much is this? Plus, so this is 123.6 minus J2 over 10 minus J8. Now you have to convert this. Now in your calculator you can do this, right? You will put as 123.6, right, minus I times 2 over 10 minus I times 8. 7.6 plus 6. So this is equal to 7.6 plus J6. I. If I want to transform this into R theta format, how would I do? This is about 8, right? So this is 64 plus 36, right? 64 plus 36. It's about 100. So 100 root is about 10. Is the approximately, right? And the angle would be 6 over 8. So A tan 6 over 8 times 180 over pi. It's about 37 degrees. So you have I1 to be 10 amperes with a 37 degree phase. There's no easy way out. You have to use your calculator to maximum. Right? Okay, here's what I'm going to do. This gentleman, he is going to use his smartphone to show you how the calculation is done. He's going to do a video of complex numbers and will send it to me and I'm going to upload it on the net. Sounds good, right? Yes. Folks, I have like 200 things to do when I go out of this room. Right? I got people calling me from the other side, people calling this side. So I forget to upload this. Immediately, if you don't see the thing at 6 o'clock in the evening, you drop me an email or send me an SMS, sir, where are the notes? Immediately you do that, I upload it immediately. I forget. Right? Old people forget. So then, sir, please upload the note immediately. Can we use calculator for the midterm? No, I don't know. I've been telling you all this time, know how to use the calculator, teach the government. No smartphones, right? No phones allowed inside the hall. You able to play no phones inside the examination hall. By accident, by default, by unknowingly, next door neighbors, no mobile phone. Because if I see a phone, you know what's going to happen? This happened last time. Immediately I come with my red pen, put a thing across your sheet. I will also allow you to do the exam. But 0 marks if I see you even being close to not a smartphone or any phone. Right? I always say, you can look down and look at your stuff to see whether you can look up to get help from God. But do not look laterally. Look straight. Right? Don't cheat as an exam result. You got caught cheating. Right? So yes, you can use calculators. Even programmable calculators are fine. I mean, you can program calculator, right? You can write notes in it. Yeah. Yeah. Whatever you can do with a calculator, you should be able to. Right? But there are no. Basically, after having stated that, I was to tell you the split as a policy. Right? Policy. On not calculators you can use. Right? I personally don't care. Anyway, bring only calculators. Anything else that I ask you? Especially questions like this. Okay. Folks, good luck. Good answer.